is waiting. That's cool. Um, Hi everyone. I'm waiting for the connection panel to say it's connected. Yeah, perfect. Um, Good morning today, everyone. So let's do some stuff. Let me know if you come online. That's pretty cool. It was, and we are live. I realize there's a lot of you watching from places all around the world, and you all found me differently. So, and I'll try and remember to do this every time I look at the control panel. Let us know where you're from. Let us know how you found the stream. That's pretty cool. Yeah. So, yesterday we did some work. Hey, Bartolomeo. Amazing. We're starting together today. So yesterday we did some work and we kind of sketched out our state machine and we got it to work. It worked. It worked really well. I'll quickly do a build and then I'll do do I have my virtual environment here or is it here? Yeah, deactivate. I don't want it in here. I want it in. I like my virtual environment here. So activate. So let's build this thing. Let's build this up. Build -b nrf 52840 dongle, and then we have to nrf 52840. 840, and then we want to -p always because we're doing development, and that should be able to build it. Cool. So the thing we want to do today why did that fail? So the thing we want to do today in RF 5252552. So the thing we want to do today is we want to go back and use the state machine that we built. And that module is here. We did build a state machine here. I'd like us to go back and build this so that we can use it across our application. And the way I kind of wanted to do that was to use events. So we have this concept of events in. I don't like that. I don't like that. I do not like that. I do not like that it can't find. Why can it not find those things? Is it because I think I know why. I think I know why. Let's finish building. So I don't like that it can't find the sources. So I think it's probably because we are using an old compiler, I think. I did do some work this morning on an FPGA and I might have messed up my Zephyr environment. But let's see. Okay, cool. So, and then what I want to do here is cp build. Okay, first of all, I'll remove the rm.rf, compile commands, yes. And then I'll cp build compile commands. And I'll copy that into here, and then I'll say that, and then that should probably make NeoVim find our sources. It's really discouraging. Yeah, that fixes it. Cool. Yeah, I did some. I had to reset my environment because I was working on an FPGA this morning. But then it's cool. Yes, Open Source Summit videos have been released. I saw that from Michael Opendaka's videos or posts. Amazing. I'm gonna check them out soon. I do want to see quite a few of the Zephyr ones. I do want to see the new features, but yeah, we'll get to that. So, cool. Maybe we should do a watch party. But that might be odd. if we watch a if I do a live stream of me watching a thing. Might not be too bad. But okay, cool. Let's go back to our live stream. So what I want to do today is I would like to use events. And these are kernel objects that are in Zephyr, and this enable us to they basically they're like a synchronization primitive or something, or almost like it's basically a bunch of flags that you can share everywhere. You can send events places. You don't have to send the data, you just want to send the flags for the events that are occurring. It's basically what I'm saying. And what we can't do is we can have our state machine sit somewhere running a thread and waiting to change states, and then we can have our applications or our threads actually sending messages up to the state machine. Some way of doing this is by posting events like we discovered yesterday. So yesterday we found a thing here. So there's this event post here. We can post an event. But then if we use an event like that, the event only tells us when something is transitioning between states. Okay? So event tells us, oh, if you were waiting for a temperature, there's a temperature ready. If you were waiting for a connection has occurred. But we still have this problem where, and I think my intuition might be the one that is wrong here, we still have this problem where in the resident thread itself, so let's go back to say the temperature thread and look at it. In this thread itself, how do I do this? Let's for one moment just assume that we wanted to we're making a peripheral Bluetooth device, okay? And a peripheral Bluetooth device is something that sits on the edges. It's basically a server. It waits for connections, and then whenever there's a connection, it will serve the connection. And this code is running on the peripheral Bluetooth device, okay? So whenever there's no server, it doesn't need to serve the connections. There might be another scenario where you need to log your temperatures and you need to hold a long running state of these temperatures. That's fine. That's okay. So you can't run this all the time. But let's say we're doing something that if you're not connected to something, if our peripheral device is not connected to something, we don't really need the temperature sensor thing to run and report temperatures because it's not reporting it anywhere. If there's no central device connected to this peripheral device, there's not really a way of reporting this. So the thing I was thinking is, if we could have a way so that whenever the application is in certain states, some threads are paused or not run, and then at some point I was sketching it out and I thought, we could do something like kthread suspend. Let me look at it. Kthread suspend. I think there's a thing like that. Suspend. Yeah. So there's this. We can do something like this. We can do something like suspension. A thread can be prevented from executing for an indefinite period of time if it becomes suspended. So look at it here. Look at this. Let's go into the code and start exploring this. But that's not really what I want to go with. But let's go in here. Let's go in here. In our here in our idle entry, in the entry. Do we want to run it in the entry? Yeah, inside the entry. That's fine. So in here we can suspend sensor thread. And then in here we can suspend, we don't want to suspend the BLE thread, we can suspend the audio thread. And this is cool, by the way. I have no problem with this one, but it kind of feels a little awkward. A thread can be prevented from executing for an indefinite period of time if it becomes suspended. The function kThread_suspend can be used to suspend any thread, including the calling thread, a suspending thread that is already, including the calling thread, so we can suspend ourselves as well. Suspending a thread that is already suspended has no additional effect. Once suspended, the thread cannot be scheduled until another thread calls kThread_resume to remove the suspension. We could do that, but then we would need the FSM to almost know about all the threads. We don't mind that. We don't mind that at all. We don't mind about the FSM knowing about the threads. That's actually what it's there for. So it either becomes an option of that. We either suspend and wake the threads as we deem fit, or we use something like events and semaphores. So we could maintain, the FSM can have a number of semaphores, and then we could maintain a list of semaphores, and then those semaphores could be, those semaphores could be used as the gates for the audio thread and for the temperature thread. So we could add 2 semaphores, one for the audio thread and one for the temperature thread, and then based on those semaphores in the audio and the temperature thread, we wouldn't do the work. But then the FSM could then release the semaphores, or give the semaphores whenever it feels as though it's good. I wonder if we can find some sort of FSM implementation in Zephyr, so that we see how someone else has done it. Let's go see if someone else has done this. Let's go see. So something like, and I probably can grab this locally, smf.h. Has anyone implemented anything that uses an SMF? Samples, subsys, SMF calculator. Can we run that? Can we run that and see how it works? Perhaps. Let's run that sample. Let's run that sample and see what happens. Zephyr samples. It samples, and then it's something like, I've seen subsys, SMF. You're the one I want. Samples, subsys, SMF. Okay. SMF. Okay, cool. SMF RSD, SMS calculator. So let's look at that. These samples demonstrate how to use the SMF system. Okay, SMF calculator. What do you do? Create a simple desk calculator using the state machine framework. This sample creates a basic desk calculator driven by a state machine. The business logic of the calculator is based on the state chart given in the UML. This is cool. What? Let's see. Zephyr samples. Subsys. SMF calculator. So let's read that here. This sample creates a basic test calculator driven by the state machine, written with this state machine framework. The business logic of the calculator is based on the state chart given by figure 2.18 of the practical UML in C++ by Myrosamek. Oh my word. Can I get this? Can I just get this this image on Google? Images, maybe? Oh, what? I don't wanna. Oh, do I wanna go find that book? Practical UMF state charts in C and C++. Oh yeah, I think it looks like it. They actually give us one, so that's fine. Why is it not opening? PDFs take long to open, and this should be back here. Okay, come on, open. Maybe book. Okay, let the PDF open, and then we can look at it. But in the meanwhile, we could build this and run it. I don't think it needs any. It does need something. Can I use modern embedded system programming course on YouTube? No, I do not know that one. Modern embedded systems. But Myrosamek. That's cool. Nice.
Welcome to the Modern Embedded Systems Programming course.
Wait.
In this course, you'll learn how to program embedded micro.
Let's Google that. Such that the quantum leaps. Is this the thing? Is this the right one? Yeah, it looks like the right one. Let's probably do a subscribe. Let's see. Okay. Cool. Can I search? Do they do any Zephyr thing? Super simple tasker. Okay, cool. That's fine. I'll look at it. That's awesome. Thank you. But what it looks like is we're not allowed to see that PDF, and I don't seem to be able to run this. I wonder if I can run it by the shell. Okay, this is such a cool way of selling stuff. Just write the code and put it in Zephyr and then like link to your book. That's so cool. That is amazing. Can I use a software display? Doesn't look like it, and I don't know. Let's look at conf shell yeah, 52. Okay, needed for boards that enable FTP, configure SMF. Yeah, do you need float? That's fine. Do you display options? I do not have the display. Well, I have a display. I'm not gonna hook it up just right now. I wish I knew I was gonna run this. And then SMF here. What do you need? Okay, this one looks better. What does this one do? Implement an event-driven hierarchical state machine using hierarchical. Yeah, but then I don't remember. I don't remember how to run. I can run it with native scene, but I don't remember how to run. What do I call this? The video emulator, the display emulator, and I don't know that I want to spend the display emulator. Okay, let me see. We have LVGL, so what we need to look at is LVGL. Zephyr. We can just look here. Samples LVGL. I know it's gonna be something in modules or something. It's not subsys. It's going to be something like modules. LVGL. So let's look at that. LVGL RSD. Yeah, cool. I just want some sort of demo where I run some sort of instruction on using native sim. Yeah, something like that. Samples to native sim, deconfig, native sim. Just build it for native sim. Just straight up build for native sim and then go run. Okay, cool. Let's try that. Let us try that. Let's just build for native sim and then run like that. So let's see. Samples, LV, module, subsys, modules, subsys, SMF. Okay, clear ls cd SMF calculator, and then in here we want to do west build dash b native sim. Do I need to say emulate something? But I don't know. Native sim dash b always. It's probably gonna explode on me. Let's see if we can run that. But really what we want is to look at the threads and see how they do them. Yeah, that's gonna build. So that is gonna build. So let's look at the the other thing I didn't know was that SMF was an actual subsystem. I thought it was just like I thought SMF would just be some little library. That's not a system. What I want to see is their code. They do have the thing. They do have the threads. Okay, so let's go to the main. That's state machine lives. Yeah. Look, that's how they build. Very a little bit of. So the thing is a little complicated. They can see how they're building events. Yeah, I don't know. Okay, cool. That's all just setting up stuff. Okay. Okay, print SMF. Show output. LV task angle. Set up display. Key message. There's probably some threads started at the top that I didn't realize. Key message queue define. Okay, cool. That's fine. That's fine. And I don't see SMF anywhere. SMF calculator thread. Okay, cool. I don't see that, but let's see SMF calculator thread. What do you do? Do you see what it's doing? It's posting an event. So, number one, our intuition is right. We want to post events. Don't really want to pause, suspend, and run threads. That's fine. No, these are just commands. These are fine. What I don't see is SMF calculator thread. I do not see the state machine framework being invoked. Which is very confusing for me. Post event, cool. I see what. Did they just okay, cool, fine. Set up display, that's fine. That's button click posts an event, that's fine. And this page is let's see, it's probably built now. Probably can run. No. Yeah, I remember this. It's in the it's in the SDL docs. LVGL. Let's look at. It's a LVGL. Sorry about the background noise. I know I need to use some sort of software video renderer, and then that should work. Modules, LVGL. No, that's the wrong place to look. Sorry about the background audio. Let's see. Modules. Yeah. LVGL. No, that's not the one I want. I just want to look at demos, and I think I need to pass in the SDL. I forget how to do it. I forget how to pass in the SDL. There's a D flag I need to pass that has the let's see. There is a D flag that I can pass that will enable me to run LVGL just now, and I don't remember it. This, the one that's causing this break. It's DL for real. Which it's like software defined video or something. I know it for video, but I don't remember it here. Okay. I do want to run the multi-display example, but I don't see why. I need to know why, how. Please don't be on all the LVGL thing. Okay, cool, demo. Where my okay, cool. this is the wrong demo folder that I opened. So it's a SVSDL. What? Use SDL with LVGL. Yeah, something like that. Yeah, something like it. You don't even need a screen. You can do this. Yes, this is what I was looking for. Native sim. Okay, yeah, but what does native sim? Yeah, but why? Am I missing something? Build for native sim, just run it for native sim. It should just run, but this, it's not. Building native sim runner, linking final executable, include, no such file, no such file. So how did they run it? Native sim, where's us build and native sim? Yeah, that's all I did. Let's see. Where's us build b dash native sim dash p dash OLED? Yeah. So it doesn't find SDL config.h, and it should. I don't think that's ever gonna be a problem because it can pick by itself, but that's gonna take a while. But the whole point that I'm trying to explore, really, to be honest, the whole point that I'm trying to explore is that the samples, the yeah, no, it's not, it's a subsystem. I did not know the state machine framework is a subsystem. I did not know that, really. State machine framework, SMF. Let's look at this one while that builds. So is the main. Okay, cool. Yeah, this one now looks a little bit more familiar. Yeah, and then they do have the FSMF here. That's cool. And then they do have a state object here. Cool. And then they do have you see the event just like us, ours, just like ours. So they do have the state event, and they have the event and the us. So we're still in a good place. What is this? What is this event? Where is this event? Where is this? Okay, it has an UN32T. So they're using their own, and then the demo events is event A, event B, event C, event. They're cool. That's fine. But this one's defined somewhere. Is this just an enum? That's cool. An enum, it doesn't have a mode domination. That's fine. That's okay as well. So yeah, they have an event object here, and then they have some states. That's same as us, and then they can do all the state initializations and stuff. And they have a probably this looks like S event S1. So S is what? S1 all the way to S211. Yeah, this is working okay. This is working completely okay. But the thing is, I want us to see is they are actually using events, which is what I thought I should do. And my thought is to use events. Yeah. Basically, what is happening is I need to run events. I need to post events. This won't work. This will not work. This will not work. Well, it will work, but it's quite very unusable. So let's put this in a header somewhere. Let's put this in a header somewhere, and perhaps once we put that in a header, let's maybe let's add 2 semaphores, and then we put them in the header, and then we kind of like and gates. Okay, let's do that. And then let's add, I think, let's add 2 semaphores. Extern struct okay, sem, and then this first one is temp sense gate. Excuse me, I don't know why that just started. Extern struct. I don't know why. Mic. I don't know what's happening. Audio sense gate. Sorry about that. Yeah, and I know I'm doing it wrong. Just hold on with me. And here, and gates. Okay. And then I want to do something like something like that. And then come to FSM service.h, and then in here I want to do that, and then I want to come back to FSM service.c, and in here I want to make I don't understand. Excuse me. Sorry about that. Actual list of actual app gates. And gates. Okay, cool. So in here, let's actually now define the two. I would say the 2 semaphores that we've included, so that we can use them. Yeah. So let's define them. I did okay. FSM service.h, Control A, and then Control E, and then I can move in between. So what I want to do is do this one's then now these are actually the structs themselves. Okay. So we can do that. We've defined those. That's cool. And then now, how would we use this? We can do something like give and take this from the FSM, and then in our threads we can wait based on this based on these two semaphores. In our threads we can wait to use them. So probably when we enter idle, we should reset the semaphores. Resetting the semaphores. Sorry, I don't know all of Zephyr offhand, so I just look up what I need to do. I kind of know what I need to do. Okay, sem reset. Let me actually check the dashboard to see if anyone has any questions. Yeah, cool. Okay, sem reset semaphore APIs. What does how do I make it none can be used right now? How do I close a gate? Okay, sem reset. Resets a semaphore. This routine sets the count of a semaphore to 0. Any and the sound takes will be aborted with a So I wanna. This is closing, isn't it? If I'm thinking about this right, this is closing. This means no one can take them right now. Wait, let's get in it. So initial count, limit. Okay, this routine initializes. So initial count semaphore created successfully. Initial count and then 0, and then let's say take. This takes a semaphore. So if I reset it, you can't use it. If I give it, you can use it. If I give it, you can use it. You can take. And then if I reset it, there's nothing available to be used. I think so. So actually, let's go into idle entry. Now we are actually using. This is now using our state machine that we've been building. Now we're going towards event-driven stuff. Now the application is becoming event-driven because we're gonna put some gates, and then based on whether some states have been achieved or not, we can now use those gates, isn't it? Yeah, I think so. So we have audio sense gate and temp sense gate, and we know in here we want to sem reset, and in here we want audio sense gate, and then sem reset and temp sense gate. I think that's it. Temp sense gate. It's not a date, it's a gate. Okay, cool. And then what we want to do is in idle, those things should be stopped. The semaphores should be stopped. And then let's put some comments in our app so that we can kind of sort of in the audio service. I want to go to here and then here. You see here. Check the audio sense gate before working. Okay. Then PV. And then in the temperature service as well, yeah, now I think we're at the point where we want to move into things into their own folders, but we'll do that just now. Check the temp sense gate before running. Okay, so what do I want to set this gate for? What I want to do actually, what I would like to do is in the FSM service, what I want to do is whenever we get into connected run, then we need an entry into connected run. Connected run actually needs an entry. Okay, cool. So I mean, connected needs an entry. Okay, static enum SMF state. Wait. This gives a void. Connected entry, and then here we want to void, and then that 0. Can even just go next. Okay, first of all, we need to do once connected, open the sense gates. Cool, but we still won't be able to get to here. So the first thing we need to do is make connected entry get connected to its state. Yeah, this is connected entry. Okay, cool. So, but okay, cool. So now this is where it becomes a little bit more a little bit more. This is where the complexity starts coming in. So whenever the app is idle, we do not want to run the audio sensor and we do not want to run the temperature sensor. Okay, but whenever the app is connected, that means it's connected to central device. We want to run the audio sense and the temp sense, but we need to tell whether the app is connected or not. I'll pause for some questions if any of you have any questions. Let me look. Does anyone have any questions? Cool. So that's fine. No questions so far. So what I want to do is I want to probably listen on our BLE thread on whether the central device is connected, and based on whether the central device is connected, what we want to do is we want to based on whether the central device is connected, we want to post an event that makes us move from idle to connected. Is that so? Is that so? Is that so? Yeah. I want us to post an event whenever we get connected, and that means using BLE callbacks. Like, if I remember well, it was like BT callbacks, BT call back, something like that. BT callback, I think. Something like BT con. Yeah. BT con CB. Yes, this is what I'm looking for. So we want to implement con CB. Okay, connection. This structure is used for tracking the state of a connection, and it is registered with the help of BT con callback register API, and it is permissible to register multiple instances of BT con callback. Okay, cool. So basically what this is telling us is we want to implement a couple of callbacks in our BLE service, and then we need to register them. And then once we register them from the BLE service, we can now post states. Okay. Connected entry. Once connected, open up the sense gates. Yeah, so that is fine. I wish I had like a to-do stub. That would be nice, so that I could put to-do stubs, and if I tried to compile with to-dos in there, it could help, but Zephyr might have something, but I don't know about it. So let's go into the BLE service first of all. BLE service, this is like the simplest service we own, because it just starts up BLE. All of this looks a lot, but it's very little. We just define a service, and then within that service we define a characteristic, and then I can actually pull up the thing so that we do. I'm starting the device. Okay, cool. So I'll show you. I will show you. It's cool. Okay, cool. So I have a temp, and let me just go back to the chat. Let me know if you know my screen. See my screen. I have a temp and light service on the application. That is the board that we're building on. And if I connect into it, it says connected, and then once it's connected, it should show me an environmental sensing service. Yeah, environmental sensing service, and then in there's a temperature sensing characteristic. Okay, cool. And that's all. That's really all this whole thing is doing. And then there's this ugly reach into some other message queue that I'm trying to get rid of, but I might not be able to get rid of. But anyways, let's do some stuff. Now, before initialize, let's do some callbacks here. So connection callbacks. Right there. Yeah, awesome. Thank you, Vladimir. I was trying to show you. So let's implement two really silly. Is there a function? Is there like a function that we need to follow when making a callback? Oh, so we get a connection and an error. This is what we need to do when we're implementing the callback. So let's implement a connected and a disconnected. So let's do a static void connected, and it takes a struct BT con, and then it takes that is a pointer to a con, and then it takes a uint 8 underscore t error. Isn't that the case? Yeah. Takes that, and then I don't even know which coding style I'm using. If what is it? 0 for success. So if error not equals 0, we failed. This is a fail. So log dash error, error occurred when connecting, I guess, and then we can do we can pretty present it here like that, and then we can do error, and we should probably another to do. Should we die? Should we die? I mean, if we were making something that's not being made in my head, we would know, because there would be like there would be log. Let's do a log warn. Connection established. Yeah, let's do that. Yeah, and then that's that. And then here, post. So let's leave a comment, a breadcrumb to come back to. I need to come up with a way of doing to-dos. I need to modify the compiler to allow me to do to-dos, but later. So let's leave a breadcrumb here. Post an event to show connected. Post an event to FSM to show connected. Okay, cool. So that can be done there. Okay, cool. And then we can do static void disconnected, and then this should be struct bt con. Same thing, takes a con. I'll only remember this until this evening, and then I'll forget it again completely until the next time I need it. Underscore t, and then error, and then in here we can do if error not equals 0, then connect. This is log error occurred when disconnecting. And then, have you ever realized? So I once did a pull request to the Zephyr code base. I've done some pretty silly ones as well. Should we die? Should we die? Should we die? These are all like later. For when this thing is too big and I don't remember what is happening, and I log warn. What do we want here? Connection removed. It feels bad. Disconnection status. Disconnection event. Disconnection event. I don't want to say connection, so because when there's a lot of logs, sometimes you're like, oh yeah, it says connection. And yeah, so something like that. And then we do that, and then so here we need to post an event to the FSM that we are disconnected. Okay, cool. Then there's that, and then that's really what we want to do. And then what I want to do is make I think I need to do like a little packet struct that we. Yeah, let's see questions. Yes. I think I need to do a little packet struct that we can give into, that we can use for, here. Remember this. PT register callback. You see this? Open a new tab. So what does this? we give it a function. We give it a sort of function. Register callbacks. I would assume I need to pass in. Why do I need to pass in a connection here? No, it's called connection callback. Okay, cool. I need to pass in a connection callback, and a connection callback has a void function that is connected, a disconnected, a recycled, Ah, I see now. You just make all of this and you stuff them into like a struct, and then once you stuff them into this struct, you just call btcon register with them. So you make all your functions, and they need to you can see here we make all our functions, and they need to have this signature or for a declaration, this one, and then if they have this, we just stuff them into this little you can put them like in a little struct because it's a struct. So you go like open params, and anyways, let's do it. Why am I explaining stuff? Okay, cool. So let's say here is are we gonna make it a static? Are we gonna make it a static? I think so. Static. And I think it's a struct. And then I think it was btcon cb. Yes. Struct btcon cb, and then we can say our callbacks, and then equals that, and then that, and then that, and then yeah, perfect. And I think this needs to end in a this because we're defining a struct, or we're rather doing an implementation of a struct, and then we can say yes, connected equals connected, yeah, and then here we can do disconnected, yeah, equals to disconnected. I think that. And then in here, after we initialize our service, before we start advertising, yeah, this one, it initializes our service here, initializes our BLE, and then in here, let's register connection callbacks. Register connection. So let's do that. And in here we want to do error is equals to btcon cb register, and then this call takes a cb that, and I think in here we want to do and our callbacks and our callbacks, something like that. What does this return? What does cb register return? Ooh, this is odd. Do you see that? The Zephyr documentation is doing something odd here. You need to file might need to file a thing. What do you return? You return an int. Oh, success. So if error not equals 0, I want that. You want this? Okay, cool. Log error connection callbacks could not be registered, and then there's that. this is a void. This is a void. So this is a void. How to handle failure. How to handle this failure? I don't know. It seems like I'm just making to-dos for myself, to be honest, because everything ends up becoming a to-do. But this is kind of this. If this builds, it can give us some logs already, and that's a beginning step. CD applications, Zephyr custom, West. Okay, let's build it. See if it works. In the meanwhile, we can do questions. See if that works. So basically, what's gonna happen is, right now, all we need to do is get logs. Whenever I connect to the thing, we need to get a log. Whenever I disconnect from the thing, we need to get a log. This is actually not good. Let me do this. There's a part here I want to remove. It will be too noisy otherwise. I won't do anything here. Otherwise it will be too noisy like yesterday. It's okay, we shall fix it, and we shall, oh my word, I want to cancel this build. I wish I had an Apple, an ARM thing would really help in the compilation speed of Zephyr. But Lumi, what computer do you use? Do you use an ARM processor? Does Zephyr run faster for you? Well, the build. And anyone else, if you have answers. That's a hard name to say if you've never seen it. Okay, we're going. No, x86, okay, go. I'm also on x86 like you, I think. Maybe I could have maybe I could put a Pi next to my desk, and then I could build on my Pi and flash from my Pi. Maybe that would be faster. I don't know. Okay, so here we go. Let's do this. Let's do this. What am I doing? I'm packing it. Control R --HW. Cool. Okay. Control R DFU. Okay, cool. I'm gonna put the app in bootloader mode. Not the app, the board in bootloader mode, and then I'm gonna be ready to do a screen here. SCM0, yeah. And then I'll push the app into it. I don't have an ARM architecture. I don't think I am on ARM. I'm running on like x86 just like you. Somehow we're crashing. And I think it's because the entry point here doesn't do shit. So there's that. There's that. I'll just do that. And then I will I don't want to do this or this. Or this. That's it. That should. I gave it some entry point that it does not like. That's the problem. Yeah, because if you have I saw someone, I think it was on Reddit, and they say they built using one of the Apple's, the new Apples with the ARM thing in it, with the ARM chip, and their Zephyr build was much faster. And that's actually making me think maybe I should just put a Pi. Maybe I should just set up a build Pi next to somewhere here, and then I can always build. I can always just somehow I can either develop on my machine and then go on the Pi and push it from the Pi or something of the sort, but we'll see. So I just removed all the noisy logs from the state machine and I'm building again. Yeah, because this is quite a slow build. I build a lot. I do a lot. I do this a lot. A lot of my day. I should run like some sort of timer and see how much I'm building during the day in Zephyr. And most of the times I'm building even huger projects, which have way more build steps than this, and then in development you kind of want to do this. You want to always do a pristine build, especially when you're changing things. Okay, let's pack it again. Okay, cool. Let's pack it, and then let's see the one that deploys it. Boom. What I really want from this step is so that when my phone app connects to the thing, I would like to see a connected log, and when my phone app disconnects, I would like to get a disconnected log, because that then we know we can post an event. We can post an event, and that will affect our state machine, which means we're using the state machine from the threads. Okay, let's see. I hope this runs. I hope nothing is crashing. Yeah, something is crashing. Somehow I'm making something that builds but it crashes. Somehow I'm making a crash. Git diff. Okay, check the audio. Bluetoothcon.h. Why are you there? Okay, cool. Static void connected. That log one. Register callback. If it's not 0. We have some sense gates. Yeah, that's fine. We removed list of app events, FSM service. We removed those, and then SMF create connected entry. And we just do 2 extant states. Check the temp. Okay, cool. I don't see why it should be crashing now. What happened here? What did we change here? Nothing? Oh yeah. We commented this out. And we removed that. And we removed that. We removed that. Connected entry. Connected entry. Once open the sense gates. That's fine. Connected exit. Connected SMF. Connected entry. It's also a void, so it doesn't need to return anything. KSM reset. KSM reset. Connected. If error. Indate T error. Disconnected. It should be a disconnection happen, not Do you have any logs after running? No, I don't have any logs after running. It's I'll show you. There's no logs after running. It actually just the terminal. You can tell. Look, and then it's gonna come back. Yeah, there's no logs. Basically, it means my thing has just crashed in an unexpected way when it was doing initialization. So I've done something that makes the app crash somehow. Once connected, KSM reset. KSM reset. Okay, I'll do this. Let me do this. Let me remove all this. Not remove. I will comment this out. And see if that actually, because that should be okay. And then here, this is okay. I don't need anything to import SEMs and such. Okay. No logs. I have a crash. I have some crash that is happening immediately on boot up. And this is the problem of having a board that doesn't have a debugger on board. So you don't get that. We're just doing DFU. No, I didn't set that. I did not set that. I maybe should. What does config boot banner do? Is it the one that says Zephyr? No, I don't have that one, but it should say when does it do it? During boot up. Okay. I don't have that one, but I can try it on the next run. Okay, custom BLE example, that is where we are in. Let's pack it. Okay, cool. And it's a pack.zip, yes. Pack.zip is what we made. Cool. Oh, it won't work because this little guy needs to be in bootloader mode. I have a feeling it's either because of how I'm doing the semaphores or because of what. Yeah, this is much better. This means it likely is going to connect at some point. This is good. So we have some sort of thing happening now. I shall see. Yeah, cool. We have it open, and I'm going to go in here. Okay, maybe I should try with the NRF connector. Oh, it connects. Yes, Baba. What do you need? What do you need? I don't understand. It's not lunchtime yet. Okay, cool. So I am connecting to the thing, but we're not getting logs. And why are we not getting logs? Must be something silly I'm doing somewhere. BLE service, BTLE con, BTLE, BTCon register. The con is here, and here we should get this. If log not 0, we should get this. And if it is zero, if it's zero, we should get that. And either we should get out of this, but we're not getting either. My logs are on. The only thing I've done is the only thing I have done I don't get it. My logs are on, but I'm not getting them. Okay. And this is stuck. My UART is also not. Kill screen. Okay. On screen. Yeah. This is the one. There's nothing. Connect. Disconnect. Nothing. So somehow I'm messing up so bad that this is broken, and I think this is not the issue. Actually, let's be clever. Let's be clever. If we do that, let's just remove the whole FSM thread and see what happens. Tell whether the issue is in FSM or not. I should get some CMake warnings and whatever. Yeah, what happens if we never start the FSM? Do we get those errors? Oh wow, I've been streaming for 1.5 hours. I could go on for quite a while, but I'm probably gonna stop since it's the weekend and go outside or do something soon. But let's get to the bottom of this fast. Let's at least discover why it's happening, and then we can stop and post for tomorrow or something. But otherwise, I need to find out why. It's crashing. It's always so easy. It's usually hard to find out what code to write. And then it's so easy to write the code, and then it becomes hard again because you have to debug the code or the application at that point. Okay, so cool, that's it. And then I'm gonna do a pack, and then I'm gonna do a DFU. Cool. It's fine, let's see. Let's see. The temperature thread should at the very least. Yes, this is amazing. So cool. This is good now. So we know it's the FSM thread that's broken. That's fine. Okay, let's see if our connection callbacks are actually working. So watch out for a connection callback. If I connect from my phone, will it actually do the connect? Connection established. Yeah. Disconnect. This connection removed. Well, that's the wrong language. Connection removed. This connection complete. But why is this? Why is this BLE module error? Anyways, I don't know why we're getting an error there. So that's number one, but we can come back to that later. So that works. I want to go to the BLE service, and I know this actually does work. These two work. This connection finished. Okay, cool. There is an error here. There's an error, BLE error 19. Yeah. Ceph BLE error 19. I don't think it's a consequential one. Yeah. BLE error 19. What does that mean? Okay, cool. It's non-consequential for now. It doesn't stop us. So let's actually fix our. Let's fix our. Cool. Let's commit some stuff, and then we can kind of go forward. Git status. How much have we changed? Okay. Git add source BLE service. Git wait. Git diff stage. Yeah. Do we actually need those ones? Yeah, okay. To git commit -m BLE service add connection and disconnection callbacks. Okay. And then the next part we want to do is I want to see git diff audio service. That's fine, that's okay. FSM service, that's where I'm going next. Yeah, that's where I'm going next. FSM service, that's where I'm going next, so don't worry about that. Thread, that's also where I'm going next, so that's fine. Main is where I'm going next, so that's fine. Git status, that looks like a lot of changes. Oh, it's just the H and the audio. Okay, cool. So what I feel like is a problem is there's something that we are doing in the FSM service. First of all, GG. Yeah, we are importing this guy. And then in here we are doing FSM.h. Is it because we need the bit? Zephyr bot. Zephyr bit utility function. Yeah, I just want to see the bit function. I feel like I don't need to. Include cctl macro h. Is that what I'm missing? FSM. Let's see. I don't think that's what I'm missing. I don't think that's what I'm missing. Okay. Before we even get to that, let's just put back the changes we did. So let's remove this. Let's go in here And then let's go in here and go like boom, 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 X, first of all. And then we want to go FSM services. See, I'm definitely going to put all of those things in. Okay. Let's actually build that and see. Okay, let's give it another maybe half an hour, and then I'm gonna stop. I think I'm gonna stop after half an hour. Okay. But I'm gonna try. I would like to try get an event posted. I'm sure. I'm just gonna speak directly to Bartholomew because you're the one who's here. I'm sure you can see where this is going. Once I can post an event from the BLE thread that something is connected or disconnected, we can change from the idle state to the connected state. And once we can change from the idle state to the connected state, we can actually open the two semaphores. And if we can open the two semaphores, we can make the audio sense thread and the temperature sense thread wait for those two semaphores. And then once we do that, we really have an event-driven application, because now whenever you're not connected, it won't do the thing, and then you get connected, it tells the thing it's connected, and then that opens the semaphores, and then the temperature microphone starts sensing, and then yes, you could do so much. So now you probably can go in the. I wonder what's the convention on going into low power mode in the FSM. So let's actually pack this. Basically, if we could be disconnect, if we go to idle, can we go to low power mode? And then once when we leave idle to connected, we can go to normal, to active state. We might need something like a wake up source or something like that. But this is an NRF, so this one has NRF power, so we don't really need to worry about sleeping yet or things like that yet. Well, I haven't learned how to do it with NRF power. So let's actually flash that and see if that works. Okay, so let's put it. See what happens then. Then we'll know what we've broken. We will know what we have broken if this goes back to breaking. Yeah, that's not good. It's still broken. Something is broken. We should see some logs. Something is arrested somewhere. So okay, so let's now actually deal with this FSM service. Let's see. Yeah, so there's some events here. There's some state here. There's some resets there. And then in idle, yeah, we don't do anything else. That's fine. So that code is stopped for now. Let's go down here in the init. I haven't changed so much, man. I haven't changed that much. Connected entry, that should be okay. That should just be this. connected entry here, and that returns that's a void, so it doesn't actually do anything, it doesn't harm anything. There's some change, there's some sort of change that I've done here. Git diff FSM service src FSM service.c. There's some change that I've done here that is breaking the app. So those ones, the sense gates, that's fine. The resets, that's okay. I added a void connected entry, that's fine. I changed this connected entry to go from connected entry, that's okay. And then I removed the post of the SMF event. Yeah, let's do the thing where we let it wait for events and then see if it actually logs anything. Let's go back to that, right? Let's go back to that, and then we can basically make it wait for events, and then we can make it wait for events, and then we can block it, and then we'll see. I don't see how this is the thing, but this can easily be the thing that has broken me before, so yeah, this is fine, this can stay. And then yeah, let's do that. Let's just build it like this now. It's definitely the FSM thread, so let's see. I'm doing a really tiny error somewhere, and that's what's breaking the build. I'm doing like some small innocuous thing somewhere, and that's what's actually breaking the app. I'm changing something without either being aware I'm changing, or I'm changing this some like tactical error somewhere that used to be valid in some legacy version or something, and then that's breaking, or I am passing around some object that's not finished or something. Any questions so far? I will we'll see. We'll try a few more times. If this doesn't work, we'll just push it up and go take a break, and then we'll come back. Does anyone have any questions so far? I'll check WhatsApp as well. No? Okay, cool. Let's do that. Let's packet. Okay, let me put the thing in bootloader. Okay, let's push the image onto it. This is fine. 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 Okay, cool. Let's just wait for events, okay? So it works. Somehow by setting, why is it leaving idle? When does it leave idle? Yeah, I should remove that. I should even remove that. Let's do that, and then we can do, okay. Let's do our sanity warning here, log 1 state machine setup and waiting for events. Let's just make sure this runs, and then we can go trigger 2 events. We can go trigger those 2. Let's make sure this runs first. So let's remove that. And then the 2 changes I've done is I've made it now, it's gonna wait forever, so it's not gonna do, there was a 10 ms timeout there. So now it's just gonna wait forever. And then it's gonna wait for event central connected. It should wait for any sort of event. This, you see this? It should be any sort of event. But for now, let's build it first. Let's build it. Let us build it. And then let's go look at K event wait. K event wait. I see. You can either wait for one event, I think now I'm here. Wait for any of the specified events. Set of desired events. I see. Yeah. So there's something here. There's a very tiny there's a detail here, and the detail is that these are all in a 32-bit integer. These are all bits in a 32-bit integer. And if you do you see this, I want this to be drop R. See this, I want this, I think it's supposed to be uint 32 events. Uint 32 events. And then you see that has a state object, because that has a state object, and in here we have a state object. So instead of waiting for the connected event here, what we're going to do is going to be, I'm actually gonna call it, instead of state object, can I call it? No, it's fine, it's called that. Dot. Do you see what happened? Do you see the change? Oh, cool. Shit. Okay. So, yeah, I see. This is not as straightforward as possible. So, yeah. So you give it a 32, a uint 32 of desired events to wait on. So you give it a 32 int, and then if any of the bits in there, you give it a 32-bit integer to wait on, and then if any of the bits on the 32-bit integer is fired, you will be told. But let's first of all do this one, the one we just built, the one that was waiting for the connected. Or do we just build another one that waits for connected? Does it make sense? Why was I building this one? To make sure it works. To make sure it works when the logs are removed. Okay. Going to put load and wood. Yeah, upload. And then to just make sure this works. So cool, that's fine. Okay, let's see that. Let's run here. Boom. Okay, cool. It entered idle. State machine set up and waiting for events. Yeah. So here we now see our problem. The temperature queue, the temperature service never waits on the events. It just does its thing. You see, but the state machine has not gotten an event. And then also, if we go and connect to it, we get a log, but the state machine doesn't get an event. Okay, and if we disconnect, it disconnects, but we still don't. The state machine doesn't get an event. So we need to associate these three facts. We need to associate that the state machine is going to happen. Okay, cool. Let me try again. What I started with. So there's this, okay? Okay, and then in here I'm going to add a couple of things. In here I'm gonna do like struct a send temp sense gate struct send audio sense gate. Okay, and then I'll make this two. I actually no. I'll make this one's externs, and then this one extern. And then what I want to do is go here and move this into the header. X. And then I want to move that into the header. And I want to move it into the header. We shall see why that now. Just go. Let's check that this actually built. The thing I'm doing is I want to be able to access these events outside the FSM module. So I need to be able to post events from another module, and then to have this the FSM react to them. That's what I need to be able to do. So I'm going to put them in the header, rebuild, make sure that doesn't break anything, and then go and try and post the events. Once we can post the events and we can see the events happening, then we'll go and implement some semaphores. We will lock and unlock the semaphores based on the events happening. And that should activate and deactivate the mic, the audio, and the temperature settings. So that's cool. That's cool. So this has been done here. This has been done here. Let's build again. So that we go it step by step and just make sure it works. Let's build this, and then once that's built and it's running, we can then work on actually going back to this little line here. We're gonna use this kind of line from connected and disconnected. We're going to use this primitive. There's a primitive, yeah, state object SMF event. That's a problem. There's a problem here. I need an extern struct somewhere, state object, because I need to touch it from a different event. You see this? I need to touch it from a different module. So I need to do a external struct. So there's a struct here already, struct state object. I need to add it to externals in the header. That's cool. That's fine. Once this is working, we're going into that, and we'll do that. And then I think we should be almost able to be done. We should almost be able to be done. Yep, we should almost be in a place where we've actually implemented our state machine. And we have it, and we should have an event-driven application. Okay, cool. So this is packed. Let's pack it. Put the guy in bootloader mode. Cool, amazing. And then let's send up the binary. Not actually good. It's actually not good because we're not getting anything. It is connecting. It is disconnecting, but we're not getting logs. I thought that would be an issue. Okay, cool. Remove these externals. That's fine. And then let's go into the service, and then let's actually just remove this. And then this, what is true here? K event wait. Okay, event wait. So it takes reset. Oh yeah, this is so insane. So this might even be the issue. Is it not dying? Yes. So this flag here, and this is very documented. Yeah, and I was reading about this yesterday. So here, let's do a false here. False. So this is actually quite a sensitive thing, and we need to be careful with it. Where was that? K event wait. So if true, clears a set of events tracked by the event object before waiting. If false, does not clear the events. So yeah, we are changing the thing that we are waiting on, and we don't know if that's changing, if that's breaking anything. Anyways, let's do it like this first, and then let's see. And then also this set of desired events to wait on is a little confusing. I might have to go back to the way I was doing it yesterday, but my brain says this is wrong. This is waiting on one single event. So and also it might not be my structs, it might be my structs, I do not know. How long have I been going? An hour 55. I'll whoever's on, do we go on until we finish, or do I stop for today? Whoever's on. Comment. please, if you're on. Do we go on until I finish, or do we take a pause for today? Because I have a feeling it's a very small thing I'm overlooking that is making it hard. Stop for today. Amazing, but okay, cool. We'll stop for today. Let's park this, see if it works, and then stop for today. Cool. Amazing. That's free. That's free. Put it on bootloader mode, and then let's load it up. And I'll commit all of this code so that if you wanna explore it, by yourself, you can. Yeah, cool. So that's on the device. One, two, three. Nothing is happening. Yeah, cool. Connect. We don't get a log. Disconnect. We don't get a log. Okay, cool. Kitchen sink. I'll do a kitchen sink commit. Okay. Git status. Git diff. Seems like it doesn't like the events being outside. There's not much in this commit, so I'll just add everything in once. Okay. Git add git status. Git add src. Git commit. -n. Kitchen sink. Broken. FSM thread. No logs. Okay. Git status. Git push. Perfect. Thank you so much for being here today, especially you, Bartholomew. That's cool. It's very nice to have someone we can do this, hold each other accountable, or rather, you hold me accountable. That was fun. It's cool figuring this out, and I think it's it's something. I'll go and think about it, and I'll go and look at other apps, and there's something I don't understand. And also the SMF examples that we saw are quite complicated, so I'll go through them very carefully, and it's probably the way we are waiting for and the way we are defining the event. Because I've realized whenever the events are outside the FSM module, it doesn't like it, but that doesn't matter because they're in the header and they're really there, they are available. So I don't know why. But anyways, thank you so much. Thank you. Cheers. See you everyone. That was cool.